6.6 Rational Expressions and Problem Solving. We're going to solve each containing rational expression for a specified variable. So we need to solve this equation for r sub 1, or r1, but it's r sub 1. That little one at the bottom is called a subscript. You might know that from chemistry and stuff like that. So what we need to do is we need to get that by itself. So we need to move everything away from it. Everything that's possibly near it, move it as much as possible. So we can definitely move the 1 over r2 by subtracting it. And when we do, we're left with 1 over r equals, minus 1 over r2 equals 1 over r1. We got there, we're getting there, but now r1, we just want r1. Not a fraction, nothing like that. So let's look at the left side. The left side is telling us to subtract, so we have to subtract. So to subtract them, I'm going to multiply the denominators together. So times r times r times r2 times r2. So on top we have r2 over r2 minus r over r2 equals 1 over r1. Gonna move this up here so we can combine like terms now. So r2 minus r over r2 equals 1 over r1. So now that we subtracted them and it's 1 fraction equals 1 fraction, we are allowed to flip it, or as we say, take the reciprocal. Why are we allowed to do that now? Because 1 equals 1. One thing equals one thing. And in order to get r1, all we have to do is just flip it. If we flip the right side, we also have to flip the left side. So now we have r2 over r2 minus r equals r1. This example, maybe watch it again. Just saying. Maybe. Alright. Hint, hint, cough, cough. Solving number problems by writing equations containing rational expressions. So kind of like what we did back in chapter 2, but now with fractions. Okay. So let's read it. The quotient of a number and 9 times its reciprocal is 1. Find the number. Okay. Quotient. That means division. Awesome. I know that. Okay. Of a number, I don't know it. So since it says quotient of a number, it's x divided by something. 9 times, so 9. Remember, if something comes before an and, you always use that something. So that's why we use the quotient. So 9 times its reciprocal is 1. What reciprocal? What are we talking about? We're talking about the reciprocal of the number. So the reciprocal of x is 1 over x. Is means equals, and then 1. So let's simplify this. We have x divided by 9 over x equals 1 as we multiply straight across. We can simplify this because we can keep, change, flip. So we keep, change, flip. If you need to, put a 1 underneath. If that's bothering you, put a 1 underneath. It's the same thing. It doesn't matter. Now we multiply straight across. And when we do, we have x squared. It's because x times x over 9 equals 1. We need to solve for x. So in order to solve for x, we need to get rid of the denominator. So to get rid of the denominator, I'm going to multiply it by 9 over 1. Because that allows me to cross it out. Now we're left with x squared equals 9. To get rid of squared, we square root, because that's the opposite. So the square root of 9 is positive negative 3. Because we're working with fractional expressions, don't forget to check your answer. Don't forget to check. So let's go ahead and check. So we have 2 possible answers, negative 3 and positive 3. So we can check it into the original or the simplified. It doesn't matter. So let's do it into the simplified version. So the simplified version, we have x squared equals 9. So negative 3 squared equals 9. Yep, that works. 3 squared. Yep, that's 9. So we actually have two numbers that can work for this. Negative 3 and 3. Solving problems modeled by proportions. So we talked a little bit about proportions in the previous section where we multiply diagonally. So ratios and rates. Ratio is a quotient of two numbers or two quantities. The ratio of a number a and b can also be written as a to b or a over b. All those mean fractions. The units associated with ratio are important. The units should match. If the units do not match, it is called a rate rather than a ratio. So a rate is like miles per hour. That's a rate because units don't match. Proportion is two ratios or rates that equal to each other. So a over b equals c over d. We can rewrite the proportion by multiplying by the LCD, which is BD. This simplifies the proportion to AD equals BC, and this is commonly referred to as the cross product. So meaning we cross multiply. All right, so if 170-pound person weighs approximately 65 pounds on Mars, how much does a 9,000-pound satellite weigh? All right, so it's telling us a few things. That on Earth, so we have two places, Earth and Mars. So Earth. On Earth, we weigh 170 pounds. And then on Earth, we have a 9,000-pound satellite. Then it says if we're 170 pounds on Earth, we're about 65 pounds on Mars. So on Mars, we're 65 pounds. So how much does the satellite weigh? We don't know. So how much does the satellite weigh on Mars? We don't know. All right, so as we set this up, we're going to put like terms with like terms. So Earth with Earth and Mars with Mars. So Earth, we have 170 over 9,000 equals Mars over Mars. So if I'm 170 on Earth, I'm 65 on Mars. You see how it goes on top with each other? Because they're correlated. So if they're correlated, you keep them together on the same level. And that's over x because we don't know how much the satellite weighs. We don't. So here, we can just cross multiply. It's awesome. So when we cross multiply, we have 170 times x, which is 170x. 9,000 times 65 is 585,000. Divide by 170. And we get x is approximately 3,441 pounds. So a 9,000-pound satellite on Earth is about 3,500 pounds on Mars. Fact, by the way. All right, solve problems about work. An experienced roofer can roof a house in 26 hours. A beginner needs 39 hours to do the same job. How long will it take if the two roofers work together? All right, so we have two roofers. We have an experienced roofer. So that's our experienced roofer. And it takes him 26 hours to do a roof. Just a couple days of work. Not bad. Then we have a beginner. So the beginner roofer. They take 39 hours to do work. What we want to know is how long if they work together. So when you work together, doesn't together mean equal? Because you're doing it together. Together means to put it together. So together, that's what we want to know. That's what we want to know. Of course, we're not going to add these, right? Because it's not going to take us longer. Why, if two people working, why would it take us longer? It should take us a shorter time, right? So bear with me here. I'm the experienced roofer. It takes me 26 hours. That means every hour I finish 1 out of 26 of that time frame, right? So meaning every hour that goes by, I finish another part of the roof because it takes me 26 hours. So every hour I'm doing 1/26 of the job. Then we're going to add that to 1 over 39 hours. And that equals 1 over x. Literally, just flip it or just put a 1 on top. That's it. Now we're going to add. So in order to add, we are going to get rid of the fractions. So to get rid of the fractions, we're going to need our common denominator. So 26 times 39 times x. And we get 1014x. So that's what we're going to multiply everything by. So we have 1014x over 1 times 1 over 26. I mean, my bad, 1 over 26 plus our LCD. So 1014x over 1 times 1 over 39. And that equals our LCD times 1 over x. So now we just simplify. So cross out. So 10,014 divided by 26, we're left with 39. 10,014 divided by 39, we're left with 26. 10,014x divided by x, we just get rid of the x. So let's write what we have left over. I'm going to write what we have left over here, because you should already have that copied down. So what we have left over, we have 39 times x plus 26x equals 10,014. So let's combine like term or multiply. So 39x plus 26x equals 10,014. Combine like terms, we get 65x equals 10,014. Divide by 65. And when we do, we get x equals 15.6 hours. That means if they work together, it will take them about 15.5 hours. And that should make sense, because if someone takes 26 hours and someone takes 39 hours, it should go down significantly, right? Because you have double the effort. So 15.6 hours. Alrighty. Cheryl can fill a bucket in 14 minutes. Cheryl and Lana can fill the bucket in 10 minutes. Find how long it takes for Lana to fill the bucket. So we set it up the same way. We have two people, Cheryl, Carol, Sherilyn, right? She goes by all those names. Lana, or Lana, right? And then together. It always ends together. So Cheryl fills it in 14 minutes. Together, Cheryl and Lana do it in 10. So it's asking, how long does it take Lana? We don't know, it's x. So now that we have those values, we're just going to take the reciprocal, put 1 over it. The reason why we put 1 over it, because we want to know how much are they doing per hour. I'm doing 1/14 of that bucket per minute, per minute. So we have 1 over 14 plus 1 over x, and that equals 1 over 10. So same thing, let's find our common denominator. So our common denominator is 10 times 14 times x. That just multiply them together, which is 140x. So we're going to multiply everything by 140x. So 140x over 1 times 1 over 14. Plus 140 over x. 140x over 1 times 1 over x. And that equals 140x over 1 times 1 over 10. All right, let's simplify. So 14 divided by 140 is 10. X and x cancel. And then 10 divided by 140, we're left with 14. So let's just write what we have left over. So we have 10x on top plus 140. And that equals 14x. All right, let's solve for x by subtracting 10x to both sides. And when we do, we have 140 equals 4x. Divide by 4. And we get 35 minutes. So it takes Lana 35 minutes to fill a bucket on her own. What is she doing? Right? What are you doing, Lana? You think with her big hands she'd be able to do it fast, but I guess she can't. All right, that's an Archer joke. Okay, so let's keep going. Solving problems about distance, rate, and time. All right, the speed of lazy river's current is 5 miles per hour. A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. Find the speed of the boat in still water. Distance. We're talking about time, rate, which is how fast they're going, and then we're talking about time. All right, we're traveling on the same river, and the river is going at 5 miles an hour. So let's draw this. All right, we have our river, and let's say it's going this way. So let's say it's you're looking at the river and it's going to the right. It's telling me that is moving at 5 miles per hour, that the river is moving that fast. So if the boat travels downstream, right, it's going with the current. If it's going upstream, you're going against the current. So you're going to go slower, right? So downstream, we're doing 20 miles. That's the distance. And then upstream, we're going 10 miles. So that's how far we're traveling. Now we need to know the rate. We don't know the rate. We don't, because that's what it's actually trying us to find, is find the rate of the boat. So we don't know what the rate is. So it's R, but we know something because it's traveling upstream and downstream. So downstream, if it's traveling with the current, however fast it's going, isn't it also going to go plus 5 miles an hour? Because it's traveling with the current, so plus 5. So however fast you have your engine, you're going to go faster because you're going with the current. It's like driving with the wind, or flying with wind. You're always going to go faster because it's pushing you. And then if we're going upstream, so we're going the opposite way, if we're going the opposite way, it's going to slow us down by 5 miles an hour. It is. It slows us down because we're going against the wind. We're going against the current. So we have to fight it. We have to work harder to get past it. So we can find our formula now. We can find we can plug it in using our formula. So we know, because we're talking about distance, rate, and time, that distance equals rate times time. And we don't know the speed of the boat. We don't. But we know how long it takes, right? It tells us. It tells us how long it takes. It's the same time. So if it's the same time, they equal each other, right? They equal each other because it's the same time. It tells us same time. So we know time is distance over rate. So time is distance over rate. So time is distance 20 over rate, so r plus 5. And then the upstream is time equals the distance, which is 10, over the rate, which is r minus 5. And they equal each other because they take the same amount of time. So we have 20 over r plus 5 equals 10 over r minus 5. Now we cross multiply. So when we cross multiply, we have 20 times r minus 5 equals 10 times r plus 5. We distribute, so 20r minus 100 equals 10r plus 50. Subtract 10r over. So when we do, we're left with 10r minus 100 equals 50. Add 100 over. So 10r equals 150. Divide by 10. And we divide by 10, we get r equals 15 miles per hour. So the boat, that's how fast it's traveling. The boat in still water is 15 miles per hour. That means if there was not a current, that's how fast we're traveling. And doesn't it make sense though? 15 plus 5, and then 15 minus 5.